video, we're going to compute the derivative of f of x is equal to 1 over x plus 2. Okay, this is going to be a little more challenging than the polynomials that we did, but it's not too bad. All right, so if we're going to apply this recipe, the limit definition we can look at as a recipe, we're going to need some ingredients. Well, we have the first ingredient, f of x. Okay, that's good. H is just a singular quantity, but now we need to get f of x plus h, because you can see that's an important ingredient in the numerator. All right, so what is f of x plus h? Well, I like to look at it this way. We have f of x is 1 over x plus 2. So f of stuff would be 1 over stuff plus 2, right? Thus, f of this stuff, x plus h, is 1 over x plus h plus 2. Okay? Great. So now we have our ingredients, and we'll put the ingredients into the recipe and bake the product. All right? So we have the limit, of course, as h approaches 0, of, what do we have? 1 over x plus h plus 2, okay, because that's f of x plus h. Now we're going to subtract f of x, so minus 1 over x plus 2, all over h. All right, so, for those of you who are fraction phobic, this may look a little daunting, but it's really not too bad, okay? We can write this fraction as, if we multiply the denominators to find the common denominator, then this fraction is going to become x plus 2 in the numerator over here, minus x plus h plus 2 in the numerator over here, whereas the denominator, as I said, is going to be the product of these two quantities. Okay, let's see what this looks like. So we have the limit as h approaches 0, right? We're going to have a big fraction. And as I said, x plus 2 is going to be in the numerator, okay? Minus x plus h plus 2, which is also in the numerator. Now I better put a parentheses around this because we're going to have to distribute the minus sign and we're going to get some cancellation. The denominator, of course, is x plus h plus 2 times x plus 2. As I said, the common denominator is going to be the product of these two things. Okay, now this is a big fraction in the numerator, and that's all going to be over h. We can't forget that because you see this is the recipe. So all we did between this step 2 and 3, okay, is dealt with this fraction, found the common denominator, and placed x plus 2 in the numerator over there, and x plus h plus 2 in the numerator here. And because it's a common denominator, we wrote it all as one fraction. All right, before we deal with the division, by h, let's clean this up a little bit. You see, we're going to have some cancellation. If I distribute this minus sign, we get negative x. So this x is going to cancel with that x. Let me do that in red, okay? So this x is going to cancel with that x. Now this 2 here is going to cancel with this 2 because the negative sign is going to distribute. So all we're going to get in the numerator of this fraction, the fraction upstairs that is negative h. That's all that survives. So we have the limit as h approaches 0, okay, of, I'll still get a fraction in the numerator, but it's not too bad. Negative h over x plus h plus 2, okay, times x plus 2, all right, all over h. Great. Now, however you want to look at it, keep, change, flip, or copy dot flip, we can write this fraction, all right, we can consider h over 1 to be a fraction, and then we can write this as a single fraction. A limit as h goes to 0 of, we're going to copy dot flip, right? So we have negative h upstairs, then we have h, and then we have x plus h plus 2 in the denominator, and x plus 2 in the denominator, right? For those of you who are good with this, you could just see that this h is going to go into the denominator there when we have a single fraction. All right, let's take the final steps, shall we? All right, so I can write this as 4 and 5. So, you know, if anybody has any questions, they can refer to a certain, you know, number. That is my students who are present now. The people who are viewing this video, I hope you can figure it out from, you know, the steps that I've taken. Okay, at any rate, so here we go. Let's cancel the h's. All right, boom. And we have -1 upstairs. The product x plus h plus 2 times x plus 2 downstairs. And at this point, we can now plug in, substitute h equals 0. You see, because we won't get 0 in the denominator. At each one of these steps before, we could not have substituted h equals 0 because we would have gotten 0 in the denominator, which would have resulted in an undefined expression. But now we can. So if I plug h equals 0 in here, we get simply, okay, let's obscure the h. So we have x plus 2 times x plus 2, which is x plus 2 squared. So we get -1 over the quantity x plus 2 squared. And that's our derivative. Good.